Okay, let me draw the graphs.
Okay.
That's the tangent graph. It's got
Yeah.
vertical asymptotes every pi.
Yeah.
Okay, and the first one goes from minus pi over 2 to pi over 2.
Yeah.
And then there's another, if I wanted to draw another period of the tangent, that would be at 3 pi over 2. And that would
Yeah.
look like this. Okay? It's supposed to look like that. Sorry, my artistic ability is lacking.
Oh, that's fine.
If you look at just the one that's between minus pi over 2 and pi over 2, what's the y-intercept?
Um, well, the y-intercept would be at 0, right? Yeah, 0.
Yep. And that's all there is to number 1. In other words, they want
Yeah.
you to look at the graph and figure out where the y-intercept is. Now,
Okay.
cotangent. I'm going to draw it on this same grid just so I don't have to. Cotangent goes from 0 to pi.
Yeah.
And it has vertical asymptotes at 0 every pi, but its vertical asymptotes are going to be at 0, pi, 2 pi, 3 pi, and so forth. And the
Okay.
cotangent curve is always decreasing. It's basically going to be like the tangent curve reflected, only
Okay.
moved over. In other words, it's not the tangent curve reflected, because if I reflected the tangent curve, say in green,
You'd have to have a phase
well,
shift of like.
right, exactly. But if they give you a curve, notice that my negative, the green is negative tangent. That's y equal negative tangent of x.
Yeah.
And the red has exactly the same shape, but it's just moved over to the right. So the negative cotangent curve looks the same as the positive, the negative tangent curve looks the same as the positive cotangent curve, only shifted pi over 2.
Okay.
Okay? So in other words, if they give you, let me give you a curve and you tell me what it is. What's that?
That could be that could be a tangent, but with a vertical.
It's in the wrong spot. Let's not deal with phase shifts yet.
Okay.
That's a
Well.
negative cotangent curve that I just drew,
Okay.
right? Because
Yeah.
the cotangent curve would look like this. And the first
Yeah.
curve that I drew was just a reflection of this one. So if this is y equal cotangent of x, then this one is y equal negative cotangent of x.
Okay.
Okay? But if I drew the curve like this, what is that? Red.
Well, that could just be sine, or it could be a shift,
Not sine.
like shifted.
Not sine. Sine is periodic. Sine's like that. Cosine's like that.
Oh no, yeah. Oh no, that's tangent. I meant tangent.
That's exactly what it is the tangent curve. A positive tangent curve.
Yeah.
Because it goes from minus pi over 2 to pi over 2 is what makes it a tangent curve, not a negative cotangent curve. Notice that it looks exactly the same as the negative cotangent curve. It's just pi over 2 shifted to the left.
Okay.
Okay? So if I wanted to throw in a phase shift, I could. In other words, I could call this the cotangent curve. I could say that that is, well, it doesn't look like the cotangent curve, so it'd have to be a negative cotangent curve, but it's in the wrong spot. It's the cotangent curve that's been shifted by pi over 2 to the left.
Okay.
So that red line could be also called the negative cotangent of x plus pi over 2.
Okay.
So by using phase shifts, you can make, there's a lot, if you just give me a curve, there's a lot of ways to define that curve. I can define that red curve as positive tangent curve, or I can define it as a negative cotangent curve with a phase shift.
Yeah.
All right, let's answer some more of these questions. What's the y-intercept of the cotangent of x? And let me draw the cotangent curve in green. And you tell me what the y-intercept is. Here's the x-axis.
Well, there wouldn't be any y-intercept.
Precisely.
Yeah.
There's not going to ever be a y-intercept on a cotangent curve that's not phase shifted. If it's phase shifted, then it might cross the y-axis. But if it's not phase shifted, it'll never cross the y-axis, no matter how many periods I have. In other words, if I draw another period of it like that, that doesn't cross the y-axis either. If I go on the other side and draw another period of it, that doesn't cross the y-axis either.
No.
So there is no y-intercept on the cotangent of x.
Okay.
Okay. Now let's talk about number 3, the secant of x. The secant sits on the peaks and the valleys of what curve?
Isn't it
It's the reciprocal of secant.
Oh, isn't that cosine?
Yeah, so let me draw a cosine curve to begin with, just to illustrate it a little bit better. Now, the very first thing you want to notice is that wherever cosine is 0, my secant curve is going to have a vertical asymptote, right? Because I would be dividing by 0.
Yeah.
So I got a vertical asymptote here. I got a vertical asymptote there. And the secant sits on the peaks and the valleys of the cosine curve. And I got another vertical asymptote there because cosine is 0 there.
Yeah.
So what's the y-intercept of secant?
That'd be at 1, right?
Correct. In other words, that's 1 right there. The one thing you know is that because the secant is the reciprocal of cosine, when cosine is equal to 1, secant has to be equal to 1.
Yeah.
Whereas the reciprocal of 1 is 1. It's the only point that they share.
Okay.
Well, and minus 1 also. Whenever cosine is equal to minus 1, secant has to be equal to minus 1. The reciprocal of 1 is always 1. So we do cross the y-intercept here at 1. Question 4, what's the y-intercept of cosecant? Well, if I draw a cosecant curve, it sits on the tops and peaks of the sine curve.
Yeah.
Which means the cosecant curve is going to look like this. With vertical asymptotes everywhere that the sine is 0.
Okay.
So
So that
what's the y-intercept of the red curve?
well, I guess there wouldn't be any y-intercept, right? Because the asymptotes
Correct.
weren't going through it.
Just like cotangent. It never goes through the y-intercept. Not without a phase shift. If you threw in a phase shift, then it would move it left or right, and it would go through the y-axis.
Yeah.
But they didn't indicate a phase shift with the question, so it doesn't.
Yeah.
Now, you don't necessarily have to draw the cosine curve like I do. In other words, you can draw the cosecant curve directly.
Okay. I guess it just kind of helps.
Well, it helps me. I'm just stuck in my old ways, but notice that the secant is symmetrical about the y-axis, and the cosecant is not. The cosecant is not symmetrical about the y-axis. The cosecant looks like that.
Yeah.
Okay? And the secant is symmetrical about the y-axis because it's the reciprocal of cosine, which is also symmetrical about the y-axis.
Yeah.
Anything that's symmetrical about the y-axis is an even function. So cosine is even, sine is odd.
Okay.
And sine is symmetrical about the origin. In other words, sine looks like this, but if I draw the negative part of it, that's symmetry about the origin.
Okay.
Cosine has perfect symmetry about the y-axis, which means secant also has perfect symmetry about the y-axis. And sine has symmetry about the origin, so cosecant also has symmetry about the origin.
Okay.
Okay. Now let's look at question number 5. For what numbers does secant of x equal 1 between minus 2 pi and 2 pi? What about secant of x equal minus 1? Well, let's draw it. I'm going to go from minus 2 pi to 2 pi.
Okay.
And we're talking secant, so that's symmetrical about the y-axis.
Yeah.
And it also means that its normal period for half of the secant is pi, because the full period, in other words, if I draw a full period of it, it's going to go from 2 pi, from this point to this point is 2 pi.
Yeah.
So when they say what values between minus 2 pi and plus 2 pi, I'm going to have 2 periods of this thing.
Okay.
Okay? And they're going to look a little bit like, let's see, that's minus pi over 2. That's plus pi over 2. That's pi. So I've got another one that I'm only going to see half of.
Yeah.
And then on the left side, I've got one that comes up from here excuse me, I'm going to see that whole thing, and I'm going to see this whole thing.
Huh.
Hold on, let me think for a minute here.
Okay.
Let's see, this sits on top of the cosine curve. If I draw the cosine curve in red, it would look like this. And if I draw the other side, it's going to come down there. That point is minus pi. And then it's going to go up like that. So the red is 2 periods of the cosine curve. So I've got more to draw for the secant curve.
Okay.
Yeah, in other words, I've got another one here that I'm only going to see part of it, like that.
Okay.
And let me erase that right there. So if I erase the red line, I'm looking at 2 periods of the secant curve. Let me erase the red line. Labels are still the same. So now to answer their question. For what numbers of x, on 5, excuse me, does secant of x equal 1 anywhere here? What numbers of x? This is 1 right here.
Yeah. Well, I guess it.
There's three values. There's 3 values where the secant is equal to 1. What are they?
Well, that's at x equals 0.
One of them is there. Okay. How about this one over here?
And then yeah, negative 2 pi and then 2 pi.
Right. That's the only 3 places where it's equal to 1.
Yeah.
Between minus 2 pi and 2 pi. Notice that the 2 pi's are included. It's less than or equal in both cases.
Okay.
Okay, where is it equal to minus 1?
It would equal minus 1 at negative pi and then pi?
Correct. Only those 2 places. So
yeah.
This is plus 1 here. Negative 1 would only occur at x equal minus pi and x equal plus pi.
Okay.
Which is a little odd, but not really. The only thing odd about this is having half of the curve that, in other words, that's what's odd about this graph. You don't often see just half of the secant thing.
Yeah.
But that's all you're going to see between minus 2 pi and plus 2 pi. And notice that we still have 2 full periods. There's the top one and that one make 1 full period, and this one and these 2 halves make another full period.
Yeah.
Okay, so for number 6, same question, only cosecant instead of secant. Well, let me draw that curve.
Okay.
I think I can do this without drawing the sine, maybe. I don't know. If I'm going to go from minus 2 pi, I'll draw the sine just to be certain. I don't think this has the funny look that the other one has. In other words, I know that goes like that, and I know that it goes like that.
Yeah.
And if I put the cosecant, there's 1 period, there's a full period of the cosecant, and notice that I can get 2 normal looking full periods on this one. I don't have any half curves.
No.
Because between minus 2 pi and plus 2 pi, it's like this. So to answer their question, where is the cosecant equal to 1?
Well, I guess it would be at pi over 2 and then negative pi over 2. Wait, oh no, it would be at negative 3 pi over 2.
Very good. And where is it equal to negative 1?
At negative pi over 2 and then 3 pi over 2.
Good. Okay. Number 7. Where does secant have vertical asymptotes? Let's do number 8 first, since I got the curve up there.
Okay.
And then we'll go back and do 7. I'll back up a page.
Okay.
Where are the vertical asymptotes for number 8? Because that's the red is the cosecant curve.
Oh,
and define them as equations of a line.
The vertical asymptotes, wouldn't they be at pi over pi over 2?
Start from
No, wait,
no.
no. Oh,
The vertical asymptotes are going to occur wherever the sine is equal to 0. Well, the sine's equal to 0 there, 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 and there. So this thing's going to have 5 vertical asymptotes.
Okay, so the asymptotes are going to be x equals negative 2 pi, x equals pi, or negative pi, x equals 0,
Correct.
x equals pi, and then x equals 2 pi.
Perfect. Now let's see if I can back up so that I don't have to redraw the other one. Okay. Where are the vertical asymptotes here?
They're going to be at negative pi over 2, pi, and
hold on, let's start from the left.
Okay, negative 3 pi over 2, pi over 2.
Okay, negative pi over 2, another one right there.
And then pi over 2, and then 3 pi over 2.
That one looks to be...
Or, pi.
Pi. No, you were right. That's not pi. That's 3 pi over 2.
Okay.
In other words, this has to be vertical asymptotes wherever cosine is 0, right?
Yeah.
Cosine is 0 at pi over 2. Down to pi, it's negative. Up to 3 pi over 2. So the vertical asymptote has to be at 3 pi over 2.
Okay.
And my scale is off a little bit on this drawing. But the key is there's 2 ways to find the vertical asymptotes. You can estimate where it's at just by drawing the line between the upper and the lower curve. But know that that always comes when the reciprocal is at 0. So if you know where the cosine is at 0, then you know where the secant has vertical asymptotes. If you know where the sine is 0, then you know where the cosecant has vertical asymptotes.
Okay.
Okay. Supposed to do 9? It looks like it's in red. That's all right. Let's do 9.
Yeah, let's do 9.
We got 3 minutes. We should be able to do 9 and 10 in these 3 minutes.
Okay.
Where's the vertical asymptotes going to be for tangent?
For tangent, it's going to be at negative. Well, starting from the left. Negative 3 pi over 2.
Correct.
Pi over.
Correct.
Pi over 2.
Negative pi over 2.
Oh yeah, negative pi over 2. Pi over 2, and then 3 pi over 2.
Perfect. And then how about cotangent?
Cotangent, it's going to be at, starting from the left, negative 2 pi, negative pi, 0, pi, and then 2 pi.
Perfect. Good timing. You got all 10 done in the half hour.
Yeah, sweet, thank you.
You're welcome. Talk to you next time, Peyton.
Yeah, see ya. Bye.